wherein we have gone ahead and proved that our relationship is an equivalence relation, and we have understood few methods of proving equivalence relation and reflexive and symmetry and also transitivity. Here I'm going to be picking up questions from exercise 1.1, the fifth question. Basically it has 5 sub questions. I'm going to be picking that up, and I'm just going to discuss that all for you. I'm not going to be proving that with statements. It's just going to be a discussion session. Okay, let's see. So this is the question that I have, right? Yes, this is the fifth question and it has 5 different questions under it, right? So what is this? The first question. What is it saying? It says that it is a relationship. It has been defined on a set A, where A is a set of human beings living in a particular town or at a particular time in a town. Okay, those two are very important terms. Let's see what this means. Let's say let's pick up a city, let's say Bangalore, okay, in a particular time, let's say today. Okay, now today X and Y are working at the same place. Now this is the relationship that's been defined to you. Let's take this particular person. Let's name this person as Ramesh. Let's say he's working for a company XYZ. Okay, so whenever I'm trying to prove these kind of questions, I need to put the statement X and Y work at the same place, isn't it? And now that's the relationship defined to me. Let's go back and check that. It says X and Y work at the same place. Okay, now what am I going to do here? I'm going to take out X. I'm going to be taking out X here, and I'm going to be taking out Y. Now what am I going to do in this place? I'm going to put Ramesh and Ramesh. Okay, so does this make sense? Ramesh and Ramesh work at the same place. Well, it does make sense. Grammatically it doesn't make any sense, but then if you logically think about it, Ramesh will obviously be working at the same place as where he is working. So hence Ramesh comma Ramesh will belong to R. Will belong to R. Basically it's proving A comma A belongs to R, and hence this particular relationship will become a reflexive relation. Got it? So we have proved that it is reflexive. Now let's pick up symmetry, right? So I'm not going to go ahead and prove that it's symmetric. Let's see how. So X and Y work at the same place. So here I'm going to be taking 2 people. Okay, let's pick up Ramesh. Let's pick up Ramesh, and I'm going to again pick up another person. Let's say this is Raju. Raju has hair on his head. Ramesh, I'm sorry, you don't. Okay, so for our example we have picked up these 2 people. So now I'm going to make this statement. So I have X and Y works at the same place. So X and Y work at the same place. I'm going to take this condition as true. This is a true condition for me. Now keeping this as a true condition, I'm going to check if the other condition is also true, which means I've already considered A comma B to be true, and now I'm going to check what is the situation with B comma A. So I'm now going to flip these 2 people. So I'm going to put this is Ramesh here and this is Raju. So now Raju, who has hair on his head, and Ramesh work at the same place. This again makes sense because let's say these 2 are working at a company or a factory, let's say XYZ, which ideally means that this guy and this guy is working at the same place. This is symmetric. So it's ideally saying that A comma B is true, which means B comma A is also true. This is a relationship under which these 2 people are related, isn't it? That's very important for us to understand. Logically, some people might be wondering, what is this? It is true, and then he goes back and proves the same thing to be true. What I'm trying to say here is this. This guy is related to this guy under the relationship R, which is defined by this. Now I'm going to be checking, is this guy related to the same guy? Okay, under the same relationship R. It is, that's how we look at it mathematically, and hence it is symmetric. Now let's go ahead and prove transitivity. Okay, now for transitivity, I'm looking at the first example here. X and Y work at the same place. For transitivity, I'm going to pick up 3 people. Okay, now let's pick up Ramesh, let's pick up Raju, and I'm going to pick up Radha. Alright, so now this is Ramesh, this is Raju, and this is Radha. Now Ramesh, so I'm going to consider the two statements to be true, the first two conditions, which is I have to say that A comma B is true and B comma C is true. Now keeping these two conditions as true, I'm then going to prove that A comma C is also true. Okay, let's see how. So first of all, I'm going to say Ramesh and Raju, this being Raju, work at the same place. Work at the same place. So let's say the place is XYZ. Okay, so Ramesh and Raju work at a company, and Raju and Radha work at the same company. Radha, which is this, work at the same company, which is XYZ. Then obviously Ramesh and Radha are also working at the same company. Might be they don't know each other, but they do work at the same company. These kind of examples are given for us to understand transitivity, how the function is going to be working and stuff. Okay, work at the same place, which is true. Therefore, R is transitive. That's all. Here, do not go in depth with the statements. Just be, concerned with the mathematical part of it. What you have to be concerned with is this. This person, which is A and B, work at the same place. So I'm taking that condition to be true. And then I'm saying B and C work at the same place. I'm taking that condition to be true. Keeping that condition, I have gone ahead and proved that A is connected to C. A is related to C. Under the relationship R defined by this. Got it? So I've taken care of the first question for you. There's nothing much left to discuss about this. Now we will look at the second question. The second question is also on the same lines. There's nothing much to be proved over there, but let's see what that is. So if you look at this, it's the same proof that I can actually take up. X and Y work at the same place. X and Y work at the same place. The same place has been replaced by same locality. Okay. Otherwise, it's the same proof. So X will live at the same place as X will live in. So X is connected to X itself, which means X comma X will be belonging to this particular relationship R. And A comma B will live in the same location. For example, Raju and Ramesh live in a particular location, Indranagar. Then Raju and Ramesh live in Indranagar, which means Ramesh and Raju also live in Indranagar. A comma B is related to R. A comma B belongs to R, which means B comma A belongs to R. So that's all. There's nothing, no superficial explanation for this. Okay, so they live in the same location. The other guys live in the same location. So Raju, if you really want to write something on this one, I would write it like this. Raju is related to Ramesh under the relationship R, whatever this relationship is, which is living in the same location. So now when I twist it and turn it around and look at this statement, I'm going to think if this is going to be true, keeping this condition as true. Well, yes, it is. And hence, this is symmetric. At this moment, it might look very stupid to you. We will do more examples where you will understand why these type of questions are very important for us to do. And if I'm thinking about, transitivity, it's again very simple. Raju and Ramesh live at the same place. Ramesh and Radha live at the same place, which means Raju and Radha also live at the same place. That's very simple. Okay. Now, let's look at the next question. X is exactly 7 centimeter taller than Y. Now, this is a very interesting question. Okay, I'm going to pick this up. The relationship R has been defined to me as X comma Y, where X is exactly 7 centimeter taller than Y. Okay, let me explain you a few things about this particular relationship R. Now, when I go back and look at this question, what does it say? It is set A is being considered here, isn't it? Set A is a set where the human beings of the particular town is being considered, right? Now, when I come back to this, what is this order pair going to have, or A class A going to have? It's going to have all the members in that particular town. All the population in the particular town goes till infinity. And all the members in this, again, the same members are going to be repeated. You getting me? So that's exactly what is going to happen in this relationship R. Alright? among these, the names are going to be repeated. The persons are repeated here, the persons are repeated here, and these people are connected under this relationship R. Okay. Now when I'm talking about A cross A, you should know that it's a very huge set, isn't it? If I am having like 1, 2, 3 till 10, so 1, 1, 1, 2, 1, 3 till 1, 10, 2, 1 till 2, 10, like that, it goes on to 10, 10, 10, 1, 10, 2, 10, 10. So that itself is too huge. So when I'm talking about two different population in a town, then the set itself is too huge. So that's why we do this in our mind. We actually don't write the set. So let's think about this question. I'm going to actually try and prove this for you for reflexivity. Okay, let A belong to capital A. I'm taking up a person from that particular town. I'm naming him as A. Can I be taller than myself? Whatever the measurement is, can I be taller than that? No, I cannot be. This is a scale, and can this scale be taller than itself? It doesn't make sense, Then it's going to be taller and taller and taller, and it's going to keep on growing. That doesn't make sense. So this basically means that A is not related to itself. Therefore, A, A does not belong to R. Or I can, before this I can actually write A is not related to A, and then go ahead and say this. Okay? Or else you can say it directly. That's also fine. Therefore, R is not reflexive. Let's look at symmetry. Okay, for symmetry, as you know, we are going to consider two people from the town, and I'm going to put the condition that A, B belongs to R. I'm going to say that A, B is true for belonging to R, which implies that A is 7 centimeter taller than B. Okay, this is a question I'm looking at. X is exactly 7 centimeter taller than Y. Correct? Now, let's go back. So, I'm now saying that this condition is true, keeping this condition to be true, which is A is 7 centimeter taller than B. I'm going to change the order, which is B is 7 centimeter taller than A. Is that going to be true, is what I'm going to be asking. No, that's not going to be true, because if A is 7 centimeter taller than B, then B is actually going to be 7 centimeter shorter than A. Let's say this is the height of A, and let's say this is the height of B. So I already know that this guy is 7 centimeter taller than this guy. So this guy is actually 7 centimeters shorter, isn't it? So the symmetric relation does not actually work on this. Got it? Therefore, I would now say that the relationship is not symmetric. Therefore, B, A does not belong to R. The first one is not taller than the second one, and hence R is not symmetric. Okay, now let's try and prove transitivity. For transitivity, let me first take the first two conditions as true. First of all, let me consider three people. A, B, C belong to A. Now, I'm going to put the condition. I'm going to say A, B is true. And then I'm also going to prove or say that B, C is also true. That implies A is 7 centimeter taller than B. And the second condition implies that B is 7 centimeter taller than C. Now, if A is 7 centimeter taller than B and B is 7 centimeter taller than C, this simply implies that A is 14 centimeter taller than C, isn't it? He's not going to be 7 centimeter taller. Instead, it's going to be 14 centimeter taller, which means A and C are not connected under the same relationship R. Yes, he is, or 14 centimeter taller than C. However, he is not exactly 7 centimeter. A, C does not belong to R, and hence R is not transitive. It's a very simple proof. Okay. Now let's look at now this is a funny question actually. X is a wife of Y. Let's look at that. Okay, so X is a wife of Y. Okay, so X is related to Y under the relationship which is wife of. for reflexivity, can this be true? It's not true. I cannot have a person to be the wife of herself, isn't it? I mean, Radha cannot be wife of Radha. That doesn't make sense. It's completely weird to actually even make that statement in English. But because we are doing it in mathematics, we are not going to be thinking on those lines. We're just concerned what is x, x belonging to R. Is that true for me? No, it is not true. It is not reflexive for me. That's the end of the story for me. Okay, I'm not going to think about anything else. Okay, now this is for reflexivity. Now I'm going to check for symmetry. For symmetry, I'm going to consider the first condition to be true. I'm so going to say this is true. X is the wife of Y. Now I'm going to flip it around and then going to check what is Y the wife of X. No, that's not true, because Y, if X is the wife of Y, then Y is the husband of X, isn't it? He's going to be the husband. He's not going to be the wife. And hence, this statement is not true. Because this statement is not true, Y, X does not belong to R. And hence, it's not symmetry. Now, let's look at transitivity. Well, I know people will be laughing right now and should be wondering, why should I even do transitivity? I don't know how it is going to go and stuff. But let's look at this. Okay. Now, let's for transitivity, I'm going to consider three people. They belong to the population, and I'm going to consider the first two statements to be true. I have to consider the first two statements to be true, which means I'm going to consider that X is the wife of Y. Now I'm going to try and take the second condition to be true. Y is the wife of Z. Well, it cannot be possible, because if she is the wife, this is a female and this is a male. Now, male again cannot be a wife of Z, is not making any sense, isn't it? I cannot take that condition itself. So we are entering into a situation where we have the first condition, but we do not have the second condition, which means this relationship R is transitive. I know. So I've gone ahead and proved that X, Y belongs to R, but I do not have the second condition, because which I cannot proceed further. In fact, in the previous video or before that video, I actually explained this to you, that if a person is not proven to be guilty, he is innocent. In the same fashion, this person or this particular relationship is going to be a transitive relation for me. Okay? X is the father of Y. What do you think? I'm just going to do that here itself. So, X is the father, which is R, the relation is the father of X. Does this statement make sense? X cannot be the father of himself. So, this ideally means that X, X does not belong to R. Isn't it? Therefore, R is not reflexive. End of the story. Next, I'm going to consider for symmetry that this particular statement is true. I'm going to be considering that X is the father of Y. Now I'm going to flip around and check if the second condition is true. Y is the father of X. No, that's not true, because Y is now the son of X, and hence Y is not related to X under the relationship R. Now I'm not talking about the father and the son relationship here. I'm talking about the relationship with respect to the mathematical terms. So Y is the father of X. Is that true? No, it is not true, and hence R is not symmetric. Now for transitivity, we consider three people, isn't it? Three elements or three people in this scenario. So I'm going to first consider the first two situations to be true, or the first two conditions to be true. So X is the father of Y and Y is the father of Z. So then I'm going to check the third condition, which is X is related to Z, which means X is the father of Z. I'm now going to think if that statement is true. That statement cannot be true. Why? Because this person is going to be the grandfather of Z, isn't it? He is the father of this guy, and this guy is the father of this guy, so this guy is the grandfather, isn't it? And hence this is not true. Therefore, R is not transitive. These questions are given to you only for our understanding and discussion of relations in a better way. I'm not going to expect these kind of questions to be coming up for your examination, but then too, it's a good to know information. If you can write the same things in statements, that should be more than enough for you. With that, we're going to stop this video. Thank you.